So let me create my board. I will solve this question. So solution. The question says that two bodies, 3.71 and 80 kilograms are 150 centimeters apart from their centers. So what do we mean? We have two bodies. One is 3.71, one is 80. Let me make one bigger. And let me make one smaller. Okay. So M1 M2 is given to be 80. Okay. So he says it is 150 cm from their centers. So this is what it means. Our R is 150 cm. But don't forget, this R is not in the SI units. So R is 150 cm, and this is equal to what? And this is equivalent to 1.5 meters. It has to be in its SI unit, as I stated in the previous lesson. Was it the previous lesson? Yeah. No, in this very lesson. I stated here. Okay. And your distance should be in meters. Okay, let's continue. So he wants us the question. Let's look at the question carefully. The question has two parts. We want the gravitational force. We want the gravitational force. So gravitational force, and that is our F. Is what we are looking for. We know that F is equal to what? And mind you, the question gave us change. So let's put it also down before we even quote our formula. You list down all the necessary information before you start working. You know that change is what? 6.67 times 10 exponent negative 11 Newton square meter per square kilogram or per kilogram squared. So we know, as I said before, we know that F is equal to what? So we are doing the A part of the question. J M1 M2 over what? R squared. And we are finding this. So we just substitute our values. Simple. And our M1 is what? 3.71. Our M2 is what? 80. And our R is 1.5 squared. You get it? 1.5 squared. And this gives us what? What do we get for the whole numerator? Yes, try with all over 1.5 squared. So what do you get? So 6.67 times 10 exponent negative 11, 3.71 times 80, and I'm getting 1.979 656 times 10 exponent negative 8. And when you divide this by our 1.5 squared, we are going to get 8.798 times 10 exponent negative 9 newtons. This is a very weak force. Very, very weak force. Yeah, so that is that. Very, very weak force. Is that clear, my people? Good. So that is the A part of the question. Now let's look at the B. The B says what? Acceleration of motion of the what? Of the bigger mass. The masses were 2. Okay. And just find acceleration of motion, not acceleration due to gravity. Acceleration of motion of the bigger mass. So the solution continues. Solution continues. And this is our B part. We want acceleration of motion. So we want acceleration of motion. And that is A, small a. It's just due to the bigger mass. And we know that the bigger mass is the 80 kilograms. Okay. We know F is equal to MA. Do you know this formula? So we can say A is what? F over M. And the F here is the attractive force between them. And that is what we got to be the 8 point what? That is what we got here on the previous page. 8.798 times 10 exponent negative 9 over the 80. And this gives us what? Divided by 80. Get 1.09975. So I will say 98 to 4 decimal place. Okay. 10 exponent negative 10 meters per second squared. That's all. That's all. So that's how you go about this question. So let's conclude. Hence, acceleration motion due to the bigger mass is what we got 998 times 10 exponent negative 10 meters per second squared. That's all. That's all. Is that clear, people? Good. So on that note, I want you to try this. This will be your assignment. Okay. This will be your assignment. So go and work assignment one. I want you to go and try this. In 2 days' time, you are submitting it. So 2 days' time after playing this audio, submit it. Please, I mean it. Don't joke and don't mess up. Thank you. All right. Let's continue. Let me solve this question for you. Two spherical masses, 4 kilograms and 7.5 kilograms, are 10 meters apart from the centers. And he wants us to calculate the gravity between them. Okay. So this is interesting. This is the question. Are we okay? Can we continue? All right. So how do we solve this question? It says two spherical, the masses are 4 and 7.5. So let's look at the solution. One of the masses is 4 and one is 7.5. Yes, they are how many centimeters apart? 10 meters. So we are giving M1 to be 4 kilograms and we are giving M2 to be 7.5. And we have been given our G to be universal gravitational constant. We have been given our G as usual to be 6.67 times 10 exponent negative 11. Okay, that's what we have been given. Then he wants us to find gravity. And I told you from the beginning of this lesson that gravity is the same as gravitational force or the attractive force. Okay, that's what we are looking for. So we know that F. So this is the A part we are doing. the usual formula. Okay, F is equal to Jm1 M2 all over what? R squared. And this is what? 6.67 times 10 exponent negative 11 times 4 M1 times 7.5, which is our M2. Okay, all over, oh, forgive me, square, I made it R2, supposed to be R squared. Okay, so and then it will be 10 squared. And when we enter this, we will get the whole of the numerator. Okay, and you divide, everything is going to give us 2.0001 times 10 exponent negative 11. That's what you get for this. All right, let us continue. Then the B part is interesting. The B says what? He wants the maximum force. And I told you that for gravity, the maximum force will be obtained when the bodies are closest. So that is the emphasis we will use to solve this question. We want the maximum force that can exist between them. And we have been given that the masses are this. The two masses are 12 centimeters. The radii. We have been given the radii of the two masses. And I have told you that the maximum force will be obtained when the gravity will be obtained when the bodies are closest. I said this earlier. Do you remember? So B. So B, our B. So we see that the maximum will exist when the two bodies are closest. When the two bodies are closest. Okay, that is when you have the maximum. What do we mean by this? That we have been given one of them to be one of the bodies according to the question. Sorry, one of the bodies according to the question has a mass of 4. So if they are closest, that is when you have the maximum. And the question has given us the smaller one and then the bigger one, you know. But I could radius here. So M1, this is the 4, and M2, This is the 7.5. So when they are closest, that is when you get maximum gravity. If they are closest, what it means is that when you check the formula, F equals M1, M2, Jm1, M2 over R squared. No. If they are closest, what it means is that R is smallest. And if R is smallest, this is greatest because F and R are inversely proportional. Do you understand now? Yes. That is what the analysis we are using here. So the question says the radii of the two masses are 12 centimeters and 40. 12 and 40. So this one will be 12. And this one will be 40. You understand? So that now our R is going to be 12 plus 40. All in centimeters. And this is what? 52 centimeters. And you know we work in meters. 0.52 meters. So that you see that the maximum force F will be M1 M2 over R squared. Okay, so that you now fix in the values. 7, 10 exponent negative 11. M1 is what? 4. M2 is what? 7.5. And our R is 0. Our R is 0.52 squared. Okay, and the rest is calculator work. Calculator does it for us. Oh, sorry, it's 400. Please, let's check the question again. The radii are what? What were the radii? Let me check it, please. Let's check the question so that we don't make a mistake, please. Oh, sorry, 412. So I made it 40. So meaning that here is 400. Oh, forgive me. So it's not any big deal. We just have to change the value. So here is 400. The question gives 400, not 40. So here is 400. 400 centimeters. So that we get, when we add this, what do we get? We get 412. and this is the same as 4.12 meters. Okay, and here we fix it here. We are going to get 4.12 squared. Yeah, exactly. Okay, and this calculator will give us 1.179 times 10 exponent 10. 1.179 times 10 exponent 10. So that will be the maximum force. Are we here? Good. This is a very interesting question. So I want you to use the same understanding you have acquired here to try this. So this is assignment question 2. Present it the same day you present assignment 1. Assignment 2. Okay, right. We'll be closing in no time. Let's look at the next item, types of masses. Basically, there are two types of masses. We have the inertial mass and gravitational mass. When we say inertial mass and gravitational mass, what do we mean by this? When we were doing forces before we went on vacation, you remember that we said that F is equal to what? What's the mathematical expression? MA. Okay. And here, gravitational mass is what we are saying here. W is equal to mg. mg. Because weight is the gravitational force exerted on a body. So these are the two forces. This inertial mass holds for any other body that is not falling under gravity. That is the difference. Okay, so that is that. Let's look at them briefly. We measure the reluctance. The nose is self-explanatory. And the gravitational mass. So the gravitational mass, you get it from either this equation or this equation. Exactly. Right. Now let's look at the differences. Inertial mass measure the body's reluctance. We measure attractive force. Inertial mass need determine acceleration. And we need determine weight of a body. Because once over here now, Added me as a way determine acceleration. Inertia need determine acceleration because in V M mu. And we use V mu. W equals mg. Okay. That is their formulas. So these are the three differences we have. Then I want us to look at a term called free fall. But before we look at free fall, I want to give you a short break. So 2 minute break. Take some water to drink. Come back. Okay. Right.